Okay, so thank you everyone for joining. Very happy to have you here. We have a lot. I'm privileged to be joined by an exceptional panel tonight, as you guys have undoubtedly seen. Tonight we're going to be exploring the topic of the future of methods. We're going to understand what the future may hold for methods and frameworks. So we're going to get our crystal ball out and see what happens. We're going to be talking about, obviously, what the future may hold for it. We're going to be discussing perhaps a world free from a methods war, as some say we are currently in. Will we continue to be led by gurus? Will experts help us so we can self-organize to create our own methods, perhaps? Lots of exciting questions and hopefully a few answers, or at least ideas by the end of tonight. So I'm Nabil, your host. We have three lovely people on our panel tonight. Robert, Uncle Bob Martin, as I'm sure many of you are familiar with. He's also boldly going where no one has gone before. So he's done too many things for me to even begin to introduce, but the short line that I wrote is a clean code instigator and a proponent of software craftsmanship. So that's my one-liner. And I'm sure I could spend half an hour just introducing all the lovely stuff he has done. Professor Bertrand Meyer, again, could spend another half an hour introducing our lovely panelists, but the one-liner is a grand computer scientist and software engineering academic and industrialist. And last but not least, our friend from Median, Professor Carlos Zapata, software engineer and futurist with a crystal ball. So very keen to hear what he has to say tonight. So those are our panelists. What they will be doing will be, each of them will be presenting their hypothesis for what the future of methods may be. They will present it to their fellow panelists and they will debate it. They will bounce ideas off of each other. They will agree, potentially disagree. Once they've had the chance at discussing the idea, I will invite all of you audience to let us know if you have any questions about it. So we very much want to hear your thoughts. Once we've had a few questions, we'll go on to the next panelist's idea for the future of methods, and we'll repeat until all three gentlemen have had their say. And that's essentially how we're going to run tonight. So just a quick introduction to Essence for Agility, the meetup group that we are. I can see a lot of familiar faces or other familiar names. So hopefully the group is, so I can see we have some, returners. For the first timers, Essence for Agility is a meetup group aimed at exploring the concept of essence. So essence is an OMG standard designed to free the agile practices from the methods prison. So methods are composed of a set of practices, and essence is essentially helping us utilize the practices in a way that suits our context without being confined by how they are used in the method that they are in. So it's a way to sort of create your own method and a way to use and embrace agile practices without necessarily attaching yourself to the method. So that's a quick one. We do events not only on Essence, but obviously on various other topics, more general, such as tonight's one. So quick intros done. Quick housekeeping. Feel free to leave your cameras on. It's always lovely to see everyone. Please try to remain muted so we can have a interruption-free conversation. When it is time to do questions and answering, if you have a question, feel free to unmute and ask it. So feel free to do that once I give you guys an indication that you can ask questions. Also feel free to raise your hand in Zoom. That really helps facilitate the questioning. So if you have a question, use the Zoom raise hand feature, and that will make it hopefully a lot more streamlined. All righty, enough from me. Let's kick off the discussion. Professor Carlos Zapata, you are up first. Please tell everyone what your idea is.
Okay, thank you so much, Nabil. Thank you for inviting me to share this panel with two of my favorite persons in software engineering, Bertrand and Robert, thank you so much for being here too. And also, thank you, everyone. I've seen familiar faces in Zoom right now. It's a good opportunity to share what we are trying to say in this meetup. I have 3 points to bring to our conversation. The first one is we are at the dawn of software engineering. Actually, the term software engineering was coined in October 7th in 1968 at Garmisch, Germany, almost 53 years ago, in a meeting of the NATO Science Committee. If we compare this evolution with civil engineering, for example, I'm a civil engineer in my graduate courses, in my undergrad courses, but I'm a software engineer in my graduate courses. We discovered that we are just starting our discipline. In civil engineering, for example, we suppose we started at 4000 BC, and the term was coined in the 18th century. Right now, in software engineering, we are just starting to unify our terminology, and this is the state of the art we have in software engineering. If we compare this evolution with civil engineering, for example, our evolution goes in a different direction than other engineering disciplines. So we start from the definition of the engineering instead of evolving to reach an engineering discipline. This is my first point. The second point is that we have many years ahead of us for reaching maturity in our discipline. Again, civil engineering is based on strong mathematical and physical principles, and it reached maturity after centuries of work. In the case of software engineering, we are based on heuristic principles far beyond mathematics and physics. We don't have these strong roots we have in other engineering disciplines. Of course, civil engineering has tangible products, for example, bridges, buildings, roads, etc. And software engineering has an intangible product, but scientific principles should be based on nature, even though we have an intangible product. We are at the beginning of this evolution, and I think the essence, this good work started by Jacobson, Meyer, and Soley, can be considered a cornerstone of our discipline. I'm very happy to share this panel with Bertrand, and we have Ivar in the audience today and tonight, depending on the time zone. But of course, I strongly believe this is a good starting point for this discipline. I think the three creators of the essence played the right role. Similar to what John Smeaton played for civil engineering in 1771, or Newton played for physics in 1687. I think they will work of these creators will remain 4 or more centuries ahead, and I think we have many years for evolving from now. And the third point I want to try to bring to this conversation is that major engineering disciplines don't have a method war. The method war is just a feature we have only in software engineering. I see no method war in other disciplines. For example, in civil engineering, we don't have a method war. This war is just a feature of software engineering. If we think about the challenges before Scrum versus rational unified process, or SAFe versus custom development method, or the traditional agile versus waterfall. These are common struggles in software engineering, but you don't hear about that in civil engineering or mechanics engineering or any other engineering discipline. If our evolution were based on scientific principles, maybe the story will be different, like it happens to civil engineering or mechanics engineering. As you say, Nabil, I have a crystal ball. This is my my way to see what will happen in the future, and my crystal ball suggests that our evolution will be based more in practices instead of methods with a proper name. This is what I think will happen in the future, because if we gain maturity in the next years, probably we will discover that we are working with the same elements in software development. All the time we are performing the same actions, we are working with similar work products, and we are creating our products, our intangible products, our software systems. We are creating these software systems with the same tools, with the same elements. And the way in which we consider right now the methods is just a branding issue. It's just the way to say that we have a special brand for a method, and we select another method in the future. I think the evolution of the methods is going there. I think in the future, the practices will prevail instead of the brand of a specific method. And in this way, all these elements we share among the methods, the work products, the activities, the dimensions, for example, we have little differences between the methods, and we are related to the same work, the software development process. So I say with my crystal ball that we are starting to evolve, that we are gaining maturity, and as we gain maturity, methods will disappear as in the way we are talking about brandings and methods in our time. And of course, we will be devoted to develop software development with good practices shared by all the methods. That's these are the points I want to bring to the discussion.
Thank you so much for that, Carlos. Robert and Bertrand, what do you guys think about Carlos's prediction?
I don't think I have a disagreement with the prediction. I think that's probably a good course that that methods are going to go through, right? We are at the beginning now, or very close to the beginning, and we're going to be evolving better methods. But the only disagreement that I would have with what Carlos said is that you don't see method wars in other disciplines or in other industries, and in fact you do, because there are always people who are disagreeing about how we should do this or that. Just to give you one example of a method war that was not too long ago, doctors threw an absolute fit when someone told them they had to wash their hands, and they didn't want to wash their hands, and they refused to for about 60 years until finally the scientific evidence was overwhelming and they had to wash their hands. Their objection at the time was, we're too busy, we can't take the time to wash our hands.
But of course, this method don't have a name, a specific name or a specific brand or something like that. It's just a matter of discussing if we can do it or not. That's the main point, no?
But now it has a name, right? Sterile procedure is a real name, and there's a lot around it. But back then, no clue, and they fought it like wild beasts. They did not want to do it.
Bertrand, what are your thoughts on this?
Well, when people attend panels, I guess they expect a bit of a blood sport, So I mean, I'm really trying to look for ways to disagree, but it's kind of hard because with such nice people and not even a single C hacker that I can see. So it's hard to disagree, but also I'm a little bit out of place in the sense that I've never quite understood what a method is in the sense of software engineering. I mean, I know the meaning of the word method in the English language, right? If I forget it, I can look it up on Merriam-Webster. But I've never quite understood people's need to be taken, by the hand, to be handheld. So I remember at the very beginning of the object-oriented wave, when I was roaming the world to teach object orientation, very successful, I should say. People were always asking me, give us a method. And when you hear this after having told people about the beauties of object technology for 2 days, when you hear this in the final session, your tendency, at least my tendency, was to say, what, should I start again? Because I thought I just did this, right? By explaining whatever, polymorphism, dynamic binding, blah, blah, and everything else. But that's not what they wanted. They wanted something like GSD or Maurice in France, or Warner or Varnier, or method, something which takes them or purports to take them step by step, which I actually don't think these things do. I mean, they're very interesting ideas, but I don't think they provide what people were really asking for, which is free me from this really ridiculous need to think. Okay, have the method think for me, and I've never understood this. I mean, because to me it's pretty clear that software development is a rather difficult intellectual endeavor. I'm not sure if I would go as far as Dijkstra, who basically compared it to the discipline of mathematics, right, of inventing and proving theorems. Maybe he exaggerated a little, but he had something, right? I mean, designing a non-trivial program, to the extent that there are trivial programs, is a challenging intellectual endeavor. And the idea that you would have a method that accompanies you from A to Z is somewhat impossible to understand for me.
And that's exactly why you were joining me to form CMAT, because we don't really believe a company should follow anything from A to Z. Instead, they should have different, let's call it practices that they can apply dependent on situation.
Right. With, of course, the risk that if you produce the method to end all methods, you are just producing one more method. Right? It's the danger of unifying efforts.
Robert, Carlos, what do you think about unifying methods? Is that another danger, or perhaps the end game, as they say?
I think by the end of the day, you have the same elements in the methods, and I agree on Bertrand's ideas about methods and the way to use methods in software engineering. Actually, we have also a linguistic difference between methods and methodologies, and this is something we need to discuss in other environments, because we always say in Agile, we say Agile methodologies, and we say plant-based methods, for example, and no one has a common agreement to know if we are working with methods or methodologies. But I think Bertrand is right in that if we want to reach from one point to another, we have a way to do it, and I don't think I think we don't need a specific name of a company telling us that this is the way we need to do it. Of course, if you review history, when we start to work with the Scrum, for example, the previous I think the previous evolution we had was a rational unified process, and people say, okay, Scrum is completely new to all of us, but if you carefully review the ideas behind RUP, you will discover many similarities between RUP and the Scrum. And for example, I don't know if in all the countries was the same, but for example, in Colombia, when companies start to use Scrum, they say to their employees, forget all about rational unified process. It's completely different. And I say, no, it's pretty similar. We are just changing the terminology. We are introducing new actors or something like that, some kind of meetings, but at the same time, we are developing the same things. We are using an iterative approach like a rational unified process said before. Just in this time, we are using sprints instead of iterations, for example. But it's pretty the same. So it's I agree on what Bertrand is saying about methods.
So on method versus methodology, there are two viewpoints there. So if you go to two perspectives, so if you go to the dictionary, you'll see that methodology means two things. It means, so in the singular, never in the plural, it means the study of methods, right? Like biology is the study of life and so on. So methodology is the study of methods, and then it cannot be used in the plural, right? There's only one study of methods. The second meaning is a system of methods. So in that sense, it can probably be used in the plural. Now the second perspective is the consultant's perspective, and it's clear that you can charge much more if you're selling a methodology than if you're just selling a method. So this is the reason for the inflation. Can I show a slide or two?
Be my guest.
Of course.
So, host, but you have to enable participant.
Oh, yes, let me give you. You are now the co-host. You have full admin privileges.
Okay, so, sorry. So I had prepared a couple of slides. So I run into this nice quote by Ralph Waldo Emerson. So as a scientist, I have to be accurate. I did not take the time, or in a few minutes, I couldn't source this quote. So I saw it on various places that cite it, but I don't know whether Ralph Waldo Emerson actually said this, or whether it's one of these apocryphal quotes that, for example, Einstein is famous for. I mean, he's famous for other things as well. So anyway, even if Emerson didn't say it, I think it's pretty good, right? And of course, to be politically correct, we replace man by person, right? This is the 19th century. As to methods, there may be a million and then some, but principles are few. The man who grasps principles can successfully select his own methods. The person who tries methods ignoring principles is sure to have trouble. Well, he was not, as far as I know, specifically talking about software engineering, but there's really a ring of truth for this. And as far as I'm concerned, I really started my software engineering career with methods. Actually, my first book was called Programming Methods. It was not published, it was not translated into English, but that's what the original French title said. And in some ways, I view myself to cite someone else as the very model of a modern methodologist. But there's more than methods, and I think this citation is quite right. So, and here I'm going to be both insufferably commercial, or at least sales-oriented, and also somewhat dejected because I've not succeeded in selling this to the world. But my work in software engineering has been based on a number of principles, and they're very strict, they're very precise. I hope they've been clearly explained, at least that has been my effort. And there are not so many of them. I mean, the main ones appear on this slide. They're not the only ones, but close. So there's maybe a dozen, maybe 15 principles. And to me, this is really the way one should build software. Abstraction, information hiding, and so on. I'm not going to go through the list. And I'm grateful that some people cite so some of them, and I've been trying to apply them, or in some cases like comment query separation to take it further. But to me, this is the first step. Methods are really for, and here I'm somehow going in the direction that Carlos they describe. Focusing on methods first is really the sign of immature disciplines. And then, the next step has been a language, to put these principles in a language. So this is not a language that the majority of the world uses. And so this is the sign of my own failure, if you like. But so why, I mean, if the whole world is going to use Python, yes, sure. We need methods, right? That's for sure. And here I'm saying this in a very humble way, because the whole world is using Python much more than it's using Eiffel. So there's something I did wrong here. So if I come out as a salesman, I come out mostly as a very unsuccessful salesman. But it has no. It doesn't necessarily mean that I'm wrong. There's also lots of people who smoke, right? It doesn't mean that they are right. I'm not directly comparing Python with smoking, but you see the general idea. So, for example, let me take just one example. Void safety, the second point on the list. So what it means is that with IFO, you have an absolute guarantee that when you do a pointer access, x.f, if the compiler accepts it, then it's not going to crash, and x is not going to be void or null at runtime. And this has actually been proved mathematically, right? modulo bugs in the compiler, which has not been proven mathematically, to have this guarantee. So this, to me, is like a switch between Roman numerals to Arabic numerals, right? It's not just in the same world. So of course, if you don't have this kind of guarantee, then you can spend a lot of time trying to have detailed methods that tell you what to do step by step, but it's really lower level technology. And then the tools. Again, I'm not going to make too much publicity for the Eiffel tools, but things like automatic testing, not just the kind of automatic test execution, but automatic test generation, or something. The last point here, which is still at the research stage, but still interesting and promising, being able to prove the full correctness of your programs. This is the kind of direction in which I want to go, much more than telling people do this, don't do that. Use a condom, things like this. It's really not. It's at another level. I would say it should come on top of having accepted principles, languages, the right principles, languages, and tools. So, if we are indeed going to be an engineering discipline, then we should accept the set of tools that people do use in engineering based on mathematics. And Essence makes a step in this direction. Clearly, I think that one can go further, but that would be my main observation here. Coming back to the Emerson quote, or an attributed quote, start with principles, and then we can worry about methods.
Mm-hmm.
That's great, Bertrand. Thank you so much for that. So guys, Bertrand, would you like to continue on to, because your slides shared a glimpse of what I predict you were going to talk about with your prediction. Would you like to share that now and continue with the slides, or are you happy to agree to our previous schedule?
So yeah, in the next hour and a half, I'm going to give you an Eiffel tutorial. Is that what you're asking? So maybe maybe it's so far it's been mostly Carlos and I. So maybe Robert should talk a little bit.
Very gracious.
Well, tell you what, that was a great pleasure. It made me want to get a cigarette and light up and smoke. All right, shall I go?
Go for it.
Okay, all right. So I was asked to talk about the future of methods, and I was struck by a number of things that Bertrand said. So I'll preface all of this with that. Bertrand talked about Emerson's quote, and that kind of stole all my thunder, because I was going to be talking about something very similar, and I will still go on to talk about something similar, but I found Emerson's quote, if it was Emerson, to be particularly insightful. The other thing that Bertrand said, other than the smoking Python person and the sea hacker thing, that I thought was interesting is that he faced a real similar problem to the problem I had. And I imagine it was probably about at the same time. I used to teach C++ to people left and right. I would go out and teach them object-oriented design and object-oriented methods, greatly influenced by Bertrand's work, by the way. And they would come back to me and say, okay, but what's the method? And I'm a programmer. I don't want to know what about methods. I just want to write code. And I would get this question over and over again. And so I went home and I thought, well, my clients want a method. I think I'm going to have to write a method. And I proceeded to write a method that might have been the most horrible thing I have ever written. Fortunately, it never got released and I never did anything with it, because I uncovered, in the midst of all of that, I uncovered the work of Kent Beck and the whole extreme programming thing. And I thought, now there is a method. That's an interesting method. It's lightweight, doesn't have a lot to it. It's really composed of disciplines. There's no flow chart for it. There's no sign-offs. It's not a big bureaucratic thing. It's just a couple of really simple ideas that you can do in order. I wasn't sure about the whole test first thing. That didn't make a lot of sense to me at first, but most of it I thought was pretty good. And as I got more and more into that, we started talking more about it and teaching it and so on. And that, of course, migrated into the whole agile thing. And that's pretty much where we are today. The whole agile thing kind of has gotten out of hand, and people have stretched it and pulled on it and twisted it and turned it. And the project managers flooded in and they've kind of taken over. And the programmers kind of feel left out of the whole thing. The guys, about 10 years ago, started the craftsmanship movement as a kind of protest against the project managers. And it's very similar. This is the kind of thing that happens in human interactions all the time. What is the future? What does the future have to do with this? What is the future of methods? Where I'm focused right now is I'm agreeing with that Emerson quote. Seems to me that methods have to be based on something. Bertrand used the word principles. I'm going to use two different words, although they tie into the same kind of idea. It seems to me that methods have to be based on disciplines. There have to be disciplines. And disciplines are rituals of a kind, things that we promise ourselves that we will do under the right circumstances. Disciplines have to be based on standards. There are certain standards we have to uphold, and we use disciplines in order to uphold those standards. Standards have to be based on ethics. Ethics are the fundamental reason why we have the standards and why we use the disciplines. Practices apply to the disciplines, which then apply to the standards, which then apply to the ethics. This is what I am focused on right now. Behind me, you will see an airplane. Turns out I'm a pilot. I learned how to fly about 5 years ago. By the way, wonderful thing to do. If you have the ability to learn how to fly, I strongly recommend it. It is a very interesting learning experience. And one of the things we learn as a pilot is that there are practices and there are disciplines and there are standards, and behind them all, there are ethics. Let me just walk you through a couple. I must not fly an airplane until I have walked around that airplane and inspected it. And there's a procedure for that inspection. The procedure would be a practice. The discipline is the act of every time doing that walk around. The standard is that the airplane must be inspected. And the ethics is kind of obvious. You'd be very upset if while you were in the air, something happened that you could have seen on the ground. That particular chain right there, just the chain of that inspection, going from a practice to a discipline to a standard to ethics, carries the force of law. The FAA, the Federal Aviation Administration, now makes it illegal for me to get into an airplane without following that particular chain. We don't have any laws in software yet. We don't have any laws governing us. There's no law that says we must practice test-driven development, or that we must practice continuous integration, or that we must practice acceptance testing. I wonder if those aren't coming. You know, many of you may have heard the prediction that I have made about the future of software. And that prediction is that our civilization depends upon us. It didn't used to be true, right? 30 years ago, the world did not depend on software. Today, the world depends on software. Nothing happens in our society without software. You can't do anything. You can't buy anything. You can't sell anything. You can't drive your car. You can't make a phone call. Can't watch TV. You can't microwave a hot dog. There is nothing you can do in the modern world without software being right in the middle of it all. Look around the room. Look out on the wall. Take a look at how many processors are running within 6 feet of you. How many processors are running in your pocket or on your wrist or on your belt? Our entire civilization now sits on top of a foundation of software written by people who do not have a profession. who have never even expressed a profession, who profess no standards, no ethics, no disciplines, and barely profess even practices. And I find that to be unstable. I doubt whether the people of the world, I doubt whether our society will tolerate that much longer. Because at some point, some software guy is going to do something stupid and kill 10,000 people at a shot. And when that happens, the politicians of the world will rise up, as they should, in righteous indignation, and point their fingers right at us and ask us the question, how could you have let that happen? We better have an answer for them too, because if we don't, they'll go away and they will determine by legislation what our disciplines, what our practices, what our methods will be, what our standards, what our ethics will be. And we will lose control of it. We will have some bureaucrats telling us what languages we have to use and what processes we have to follow and what signatures we have to get. So we'd better get there first, and we'd better define the standards, the disciplines, the ethics, the methods. We'd better be there with that. Otherwise, we're going to be facing many long years of wintry bureaucracy holding us down into a place I don't think we want to be. And that ends my position.
Yeah, a side comment on something that Robert said about, people developing software kind of without any standards. I remember hearing from a colleague at Microsoft Research statistics. I forgot the exact number, and it was just like a cafeteria conversation. So don't take it as a scientific fact. But I tended to trust what he said. He said that according to their studies at that time, maybe that was 10 years ago, or so. So we can always hope that things have changed. I would doubt it. But he was doing proofs of. Or not proofs, but verification of device drivers. Okay? And one thing that they had found is that in something like 2/3 of the case, I forgot if it was 60% or 70%, but that order, the person writing a device driver was writing his or her first device driver. Okay, which posed huge problems to the people in charge of Windows, trying to make sure that, of course, the device driver from the little, this is actually I don't know, it probably doesn't show. Yeah, this is my latest gadget. It's not as fun as Robert's gadgets, but it's just a ventilator. It's a ventilator that in the summer I find useful. A very small ventilator that I plug in. It plugs into the USB port of my computer. I guess to any USB port, but I can plug. So the person writing the device driver for this thing, assuming it has a device driver, is an employee of the device driver company. And probably a hardware engineer, probably a ventilator engineer, and his or her knowledge of the intricacies of modern software engineering is probably fairly limited. So this also puts a strong limit to whatever we can do. I mean, this is also a unique property of software, right? It's highly unlikely that someone who is not an advanced chemical engineer is taking part in the development of advanced chemical devices or tools. But in our field, it can absolutely exist, partly because of the lack of professional qualification. People like David Parnas. Well, actually, this is what I just said is a contradiction in terms, right? There are no people like David Parnas, or more precisely, the set of people like David Parnas has a cardinality of one. It includes David Parnas. So David Parnas has been arguing for a while, for a long time, for professional qualification of software engineers. I think he himself, he was very proud of becoming a qualified engineer, a certified engineer in Ontario, but that has not succeeded on a large scale. So essentially anyone can start writing software and does write software. Now, it's not necessarily a sign of sloppiness or incompetence, okay, in the field. It's actually because there are some real difficulties to adopting the kind of rigorous scientific approach that other disciplines have. So maybe I'm speaking, I have a little more to say on this, but maybe I'm speaking too long. So should I wait or should I continue?
I would love.
Yep. I think Robert is bringing to this discussion several terms that we need to review carefully. Robert talks about principles, disciplines, standards, and sort of. And what we don't have in software engineering is a real unification of these terms. We have problems even with the standards. If you review, for example, Square and 29110, you can discover differences between the standards we have in the ISO standards. So what we are reinforcing at this point is the need for maturity that we have in software engineering. And this is what we expect to have in the future of software engineering. And of course, this topic about methods must evolve in the future by incorporating the words Bob is bringing to this discussion. We have to be aware about what are the principles, as Bertrand said, also in terms of software engineering, and we need to unify this entire situation in order to avoid what Robert is warning us about, the danger of creating software without persons done professing the way to develop software.
So let me try to go a bit further by explaining why it is so difficult to get really concrete progress on methods. So if we look at software engineering research, so here I'm taking the viewpoint of a researcher, but that includes applied research. There are, I believe, 4 categories of software engineering research, which we can group into 2 broad categories: constructive, conceptual, analytic, and experimental. So the first 2 go together, the second 2 go together, but they are all different. So constructive research, it's people who build things. You know, I build a compiler. In the old days, I build a browser. Nowadays, it would be I build an IoT system. You know, I build an interesting product and I present it and explain in order for it to get published why it is interesting. Then you have conceptual. Maybe I should have started with this. Conceptual is close to constructive, but what we're building are not products, they are concepts. So in another area, meaning computer science education, someone came up with the term Marco Polo papers. You know, I traveled very far, I saw big things, and here they are, and you should be impressed. So constructive and and conceptual. So, for example, this is a large part of what I have done, for example, because it's very tempting when you're full of ideas to come and convince the world that you have the best thing for them since sliced bread. Then you have analytic and empirical. So analytic takes stuff, software stuff, but in a very broad sense. It can be management processes, it can be, of course, code, but it can be requirements, it can be tests, and analyzes it. So the kind of epitome of analytical research is software verification, which takes programs and tries to prove or disprove their correctness or to find flaws in them. And then you have empirical research, which is this, like analytical, but it's quantitative. And of course, this has been a major development in software engineering research over the past 20 years. One of the people who have actually made major contributions to this is in the audience, Tom Gilb. If you look at ICSE papers these days, International Conference on Software Engineering, it's clear that the empirical school has won. I mean, you measure everything there. But if we talk about empirical research, it again has two variants. Product research. I mean, we can be assessing, it can be measuring products, or we can be assessing projects. Okay, so product is the part that works, because you can take the repository of Linux going back 30 years, of Eclipse going back almost the same, Eiffel Studio, so, and you can mine, especially using data mining techniques, even machine learning techniques, like you can deduce very interesting properties. But what we would need for methods is empirical research applied to processes. Okay, is it better to have daily, very importantly, Robert brought in agile methods, which of course are undoubtedly the main method contribution over the past 20 years, before Essence, of course. Do we really need a daily stand-up meeting? I mean, to ask a somewhat silly question, but not so silly after all, should it be a stand-up meeting or should it be a sitting down meeting, right? We could go fine grain, or we could go large grain. Is Scrum better than
That's a very good point, Bertrand. I think the sitting down or standing up, that's been discussed many times.
Right.
Guys, I'm keen to hear what the audience have to say, because I'm conscious we haven't given them an opportunity to raise their hands.
This point that we need metrics. Okay, we need quantitative measures on this, and as easy it is or feasible it is to get metrics on products, it is extremely hard to get metrics on processes, because we're talking about very expensive processes, and it's very difficult to get replication. What works for one company is not necessarily going to work for the other company. So to me, this is the basic obstacle today in making progress with methods, is the difficulty of obtaining credible, quantitative, empirical evidence.
Excellent points. Thank you so much, Bertrand. I can see Adam has his hand up. Would you like to unmute and ask your question?
Hi there. Thank you for coming to me so soon. So my background, I'm literally a rocket scientist by training, aerospace engineer. You can go for charter status in those kinds of engineering disciplines. I think the difference I see between software engineering and other engineering disciplines isn't the fact that there is a huge amount of engineering skill required, but due to the fact that aerospace engineering is a complicated subject. It's reducible down to pass-fail criteria, whereas software nowadays is building very large complex networks that are extremely difficult to analyze for pure pass-fail criteria. And if you think about the different aspects of engineering, those that are reducible, chemical engineering, electrical engineering, mechanical engineering, these are relatively simple models that get built up, whereas software I see as being a very complex domain. It's closer to mathematics. I'm wondering whether or not that might make a chartered engineering in software far more difficult. because you don't get it in every aspect of engineering. I just wondered what the thoughts of the panel were on that point.
Of course, one of the practices that I like to follow is test-driven development, which does in fact reduce even very complex systems down into pass-fail criteria. We do, however, have this new idea of machine learning and artificial intelligence, where we base everything off of coefficients, that are wired into neural networks, and those don't have well-defined pass-fail metrics. I wonder if at some point in time, whether the society that we live in will come back and say, we don't want to live being with a bunch of machines that we don't understand, that we cannot reduce down to pass-fail criteria. I imagine that'll happen the first time some self-driving car kills a 2-year-old.
That's quite a statement to end on. Okay.
Well, I think we passed that period a very long time ago with power networks, for example. Power networks are irreducibly complex, and we just build in tons of redundancy, but we don't really understand them. So you can get away from complexity by just chucking in redundancy, and then we can do that with almost any system. But I think it's what makes I wasn't trying to be awkward here, but I'm just wondering whether there's something about software engineering that is fundamentally different to those different aspects.
Yeah, there is. I mean, we tried redundancy, right? So some of us are still remember this. There was a theory which was popular for a few years called inversion programming. Okay, and the idea is that you give the same problem to several groups, and then you have a voting system like you do in hardware. The problem is that you can be in Zurich, you can be in Chicago, you can be in Zambia. You've probably learned programming from the same textbooks and from the same schemes, and you make the same mistakes. So, the redundancy works if there's some independence hypothesis that applies. It doesn't apply to the way people think. People think remarkably similarly. Right.
The first scrub of the space shuttle was due to the failure of that voting system to sync up.
Right.
Thank you so much for the question and answer, Adam.
Thanks.
Panel.
Thank you.
So, future of methods. Keen to hear if anyone has a specific question for Robert, based on his, the most recent idea he posited. Hussam, you have your hand up. Do you have a question about the future of methods or anything that any of the ideas that the panelists have presented?
Yeah. I actually reflect a little bit about everybody's talks, and I think actually what our problem is that there is a quality problem. We don't know what requirements are asked to be fulfilled, and we don't have the qualitative and quantitative measurements, the metrics that Bertrand was talking about, to measure the value creation for our stakeholders. If we have that in order, we will have the standards that Robert also is talking about. We will have the ethics, and we will have the measurements how to realize the benefits. Is that right, or what do you think?
Yeah, I think it relates to some of what I was saying a few moments ago, which is that it's very difficult to conduct realistic experiments. Even with processes other than software processes, the whole Taylor industrial engineering movement is based on this. You take one hypothesis in one factory or in one assembly line in the factory, use a different technique in the other assembly line, and then you have people with their time watch, with their clocks, measuring what employees do and measuring the output at the end, and then you can say method A is assembling this piece before that piece is better than doing it the other way around, and it kind of works. But unfortunately, in software, it doesn't work like this. I think it can work for fine-grained things, but for the big issues, it doesn't. Because if you want to conduct an experiment, first you need to reproduce it, and if it's a different project, then you can always explain the different results by the characteristics of each project. And then even if company was rich enough to have a project done several times, just in order to compare the techniques, to compare the results of different techniques, then people would say, well, it only works for IBM or whatever the company is. So we would need to do it across the whole industry. People would have to be willing to share the results, which typically companies are not. So this is what has stopped us from having a really scientific approach to method evaluation. And so the way it works is that once in a while, a new idea comes in, and it's so clearly superior. I mean, once people actually try it, then everyone says, yes, that's what we need to do. And this is what happened with object-oriented development. This is also what happened with Agile, or at least some elements of Agile. At some point, people just said, yes, it's obvious. We don't need any stupid measures, okay? We're just going to do it because it works so much better for us. But then it means that the threshold is much higher because it has to be absolutely, evidently, unquestionably better than everything that was before, that existed before. And so this doesn't quite allow for incremental improvements for which we would need scientific empirical measurements.
Yes, but isn't that actually a little bit two sides of the same thing? Because if you look at the embedded software, it has higher quality than the usual high-end software. And I think that is because of that. We require that hardware to function. We require the embedded software to be of high quality. There are standards that it has to comply to. While in the usual web development, for example, we don't have any standards to comply to. It's just speed, velocity. And as Tom Gilbert said to me the other day, if you multiply 6 by 0, you will get 0 at the end. Velocity doesn't mean anything.
But this is the problem with immature disciplines like we have in software engineering, because you don't have an agreement about what are the measures, what are the way to obtain such measures. If you look at the square, the 25,000 standard of the ISO. You look at the measures they have there, and we don't have an agreement about what to measure, what are the features you can measure, and all this stuff. And if you compare this with the CMMI, for example, you see no intersection between the main aspects you need to measure. So this is the problem of maturity we have.
Great question and answer, guys. Thank you so much. Okay, there's about 10 minutes left. Bertrand, could you please, as our final panelist to present an idea, could you just spend maybe 2 minutes presenting your idea? Brevity is key, and then we can try to have a quick discussion about it to close out this call.
I think there has been too much of a reluctance of the industry to choose tools and methods and languages based on actual value rather than based on what everyone else is doing. And the path to progress rests on, or actually, a way doesn't rest. The path to progress depends on accepting that technical criteria, which of course include economic criteria, because what counts is not how pretty your program is, it's whether it's going to bring money to the company. So technical criteria in a broad sense are really the ones to be taken into consideration, as opposed to many criteria that often do play an exaggerated role in practice, like, is this acceptable? Will my management blame me for, in the old saying, not buying IBM in a metaphorical sense? of buying IBM, or will my programmers complain that they have to learn horror of horror, some logic? Okay? These kinds of short-term excuses have really caused a lot of trouble, a lot of damage to the industry, and they should take a second step to a second role as compared to the only criteria that matter in the end, which are the criteria of quality. Let me also mention, I am not quite within your 2 minutes, but you're using another 30 seconds. Let me mention something that I've been repeating again and again to exhaustion of me, not of me, I'm still there, but of my readers, which is that we are really missing something critical in software engineering, which is the legal requirement to explore the failures, the reasons behind software failures. You know, every once in a while, actually quite often these days, you see headlines about some software system crashing. Usually it's about security, but not only. And then nothing happens. You know, you never see a headline with an explanation of what actually happened. So it happened, for example, it happened once, a few times, but it famously happened once with the Ariane 5 crash. And this was a tremendous boost to software engineering because everyone could see what was the problem and propose his or her pet theory to or language or tool to solve it. But that's good. This is how, for example, airplanes, since we have Robert's plane behind him, this is a very opposite comparison. The way airplane travel became extremely safe is that over the course of more than a century, after every crash, there's been legally an obligation to perform a systematic study. And so airplane travel went in that century from an extremely dangerous sport to the safest way of travel. And until we have this kind of obligation, every time there's a serious crash, software crash, or in particular anything involving taxpayers' money, to have a systematic study of what went wrong with an obligation to publish, until we have that, we're still going to work more or less in the dark.
If you want to be truly terrified, read the study of why the Toyota cars killed several dozen people when their engine control software blew its stack. And the cars accelerated out of control and smashed into things. And the review of what was wrong with that software was very stark and very frightening.
I will. I don't know that study, but I will get it from you.
That was a comment to the general group, but I'm happy to send it to you.
Well, I'm not saying that others shouldn't get it from you, but I'm very selfish.
So, Carlos, what were your thoughts on Bertrand's idea?
One of the things Bertrand mentioned is very curious. Try to look at the legal requirements, for example, for software development in any country. I think this this kind of requirements is pretty different from country to country. If we don't have the possibility to join all this information and have a standard qualification as we have in other disciplines. We don't have, for example, a document with the legal requirements of software products in Colombia. We don't have that. We don't always, the companies have their own methods, their own ways to work with software, and no one has a set of legal requirements to be met in a software application in my country. I don't know if it's in England or something like that.
We have the same elsewhere, and that's exactly what I'm complaining about. But and of course, we don't want to destroy a free enterprise and company privacy, but it can be imposed in cases in which either the public is affected in a major way, and or taxpayers' money is involved. Then there could be that requirement.
So the idea seems to be that the future of methods has a lot of legal implications and will be legally bound. That seems to be the general consensus that the last few questions and comments have been directing us toward. Any other thoughts on that, particularly around any of the more future-gazing comments that we've had tonight from our panelists?
Well, the legal aspect, I think, is definitely coming. My hope is that we can get there first and lay out the rules that they turn into laws. Otherwise, they're going to invent their own, and it's not going to be good.
Okay, wise words. Thank you so much. I'm going to take one final question from the audience because I'm conscious of time. Alfonso has patiently had his hand up for quite a while. So Alfonso, would you like to unmute and ask your question potentially around any of the ideas our lovely panelists have presented tonight around the future of methods?
Yes, I'd like to make a couple of remarks. One, the legal implications and the ethical questions on the software are ones that will have to be done in order to help make this a true engineering discipline rather than seat of the pants, cowboy coding, trial and error techniques or processes that people are using now, the chaotic level of maturity that we're at right now, according to CMMI. Addressing Adam's concern as why it's so difficult, the thing is that software has fundamentally only 5 things in which everything else is derived from. Everything else is
Looks like you muted yourself, Alfonso.
Constants, variables, control structures, functions. That's basically. I'm forgetting the 5th one, but that's it, and everything else is a combination of that. So if we separate, we break everything down into those elements and separate the functions that we use into both infrastructure and the domain problem, then it becomes easier to quantify and provide analysis for what we're doing. We're not doing enough in software architecture to really make this an engineering discipline. But what I know that Robert had said that we've kind of hit the limits as far as designing software, but does he really feel that architecture, which he's done some presentations on before, does he really feel that our knowledge of architecture is sufficient? Thank you.
The question, if I understood the question properly, was, do I really believe that our knowledge of architecture is complete or limited? I couldn't quite get the last word.
Yes. Do you feel that we have a sound basis of architecture, or can we learn from other engineering disciplines more about what constitutes good architecture, good programs?
It's an interesting question. I do think that we know an awful lot nowadays about what makes a good software architecture. And I think we've learned that by looking at a lot of very bad software architectures. Are there other disciplines that could teach us more about software architecture? Interesting question. I'm not an expert on other disciplines, so I don't know that I can answer that. I would say, though, that software is different enough that I would be surprised if something came in from a very different discipline. Although maybe I should counter that, because I often make the comparison that some of our disciplines are like accounting.
Yeah, well, on the other hand, after everyone having said lots of bad things about software, I think we should also be somewhat proud of ourselves. I mean, as Robert said at the very beginning, software runs the world, and actually much of the time it works. I mean, we want it to work all the time, but to me, we're 50 years old, right? We are 50 or 60 years old as a discipline, and we tackle systems of a complexity that I think is unheard of in other engineering disciplines. The complexity of a software system is more akin to that of a human system, like a city. But of course, in a city, lots of things can go wrong, and do go wrong lots of the time. In software, everything has to be right more or less all of the time, right? You can change you can turn off a single bit in Windows and your computer doesn't work. You can also turn lots and lots of bits off in Windows and things will still work for a long, long time. But it's very difficult to know which bits you can turn off. So think of the complexity of the things we build. In many cases, I think it's the other disciplines that also have to learn from us. I know we're out of time, but things like new materials, for example. If you look at new materials, which is a very active discipline, it's not really it's halfway between physics and engineering. But what they really want to do is to program new materials, and I think they have a lot to learn from us, and my price list for consultant fees are available on request.
But in the other direction, we need to learn also from the other disciplines. I think one of the concerns about Alfonso's question is related to the formality of the way to treat things in software engineering. For example, the way to reach the main elements for defining an architecture, for example, or for defining anything in our field of knowledge is what I like the most about Essence, because Essence right now is defining a set of elements that we can use to describe anything in our discipline. Is what we are doing right now by unifying terminology and making people aware of those elements in every country we have. Right now we are working on Essence. On Essence representations, and I'm very surprised that such representations we are creating are understood by people in every country we have on Essence. This is the main terminology we need for explaining our phenomena in software engineering, and I think it's something Alfonso's mentioned on his question about the formality and the elements we need to describe things in software engineering.
That is a great point. Thank you so much, Carlos, and very relevant to our Essence for Agility group, naturally. Okay, thank you so much, Alfonso, for the question. Sounds like we have a lot to learn from other engineering disciplines and vice versa. Panelists, thank you so much. Audience, thank you so much Bertrand, Carlos, Robert, Uncle Bob, you guys have been fantastic. Thank you so much for your insights and your future, your idea of what the future of methods may hold. Usually this is where we do a round of applause. I'm just going to clap in my room, and anyone feel free to join me. Feel free to unmute as well. So it's not just me clapping. Thank you so much.
Excellent moderation.
There we go.